So hi guys, welcome again to another video, and for this video I'll be summarizing the chapter 3, which is the network protocols and communication. So let's start. We have the establishment rules. We identify the server and the receiver and the common language and grammar, the timing and speed of the delivery, and the confirmation or acknowledgement requirements. So the protocols are used in network communications to share many of these fundamental traits. And in this tradition, in addition, identifying the source and destination, computer and network protocols define the details of how message is transmitted across the network. Common computer protocols include the requirements, and each of these will be discussed in more detail. So we have the message timing. So we have the access mode, and it determines when someone can send message, when to begin sending messages. So if two people talk at the same time, a collision of information occurs and it is necessary for two to back off and start again. So it is necessary for the computers to define an access network. So on a host network need an access method that to know how to begin sending messages and how to respond when collisions is occurred. So next one, we have the flow control. So it is the control the time of two frames. So timing is also affects on how much the information can send and the speed that it can be delivered. So for example, if one person talks or speaks quickly, it is difficult for the other person to hear or understand the message. In network communication, the source and the destination host use flow control methods to negotiate the correct timing and successful communication. So we have here the response timeout. And for example, if a person asks a question and does not hear and responds with the acceptable amount of time, the person assumes that no answer is coming and reacts accordingly. So for this, the person will repeat the question or go on with the conversation. So if we talk about the network, the hosts on the network also have rules and specify how long to wait and response, and what action take it to response, and timeout occurs. So let's proceed to the next one. We have here the unicast, the multicast, and the broadcast. So I will explain to you the difference of the three. So that's for the message and delivery options. So for the unicast, for example, one person is talking to another person, another one person. So in networking, we have the one source going to only one PC. So that's for the unicast. Just only for the one. So for the multicast, if the person talk or speaks and there will be a two person will receive the message coming from the person. So in networking, we have the source and the message will deliver and it will go to the two PC. So for the multicast, it is for the two two persons or anything. So for the broadcast, we have for example, we have the one person gives a message to all of the audience or people around them. So it will the message will receive all of the people that is listening to the person. In in networking, we have the one source and it will send message to all of the connected to that source. So for the unicast, we have 1-1, and for the multicast, we have 1-2, and for the broadcast, we have 1-many. So let's proceed to the next one. We have the protocol interaction. So we have the HTTP, TCP, IP, and the Ethernet. So for the HTTP, that is the application protocol that governs the way a web server and a web client interact. So it defines the content and formatting of the request and response that are exchanged between the client and the server. So it relies on a protocol to govern how messages are transported between the client and the server. So for the next one, we have the TCP. So it is a transport protocol that manage the individual conversation. So the TCP divides the HTTP messages into a smaller pieces that is called the segment. So that segment is sent between the web server and the web client. So process running at the destination host. So TCP is also responsible for controlling the size and the rate which is message are exchanged between the server and the client. So for the next one, we have the IP. So it is responsible for taking the formatted segments from TCP and encapsulating them into packets and assigning them the appropriate addresses and delivering them to the destination host. So for the next one, we have the Ethernet. That is the network access protocol that describes two primary function. The first one is communication over a data link and physical transmission on the network media. So for the network access protocol are responsible for taking the packets from IP and formatting them into the transmitted to the media. So for the next one, you have the benefits of using a layered model. So a convention structure, since conventions that work at a particular network have characterized data that they follow up and characterized interface to the layers above and beneath. So encouraging challenge, since items from the various merchants can cooperate, and averting innovation or capacity changes in a single layer from influencing different layer above and beneath. So giving a typical language to depict organizing capabilities and abilities. So I read the original benefits using a layered model, but I'll just put the explanation or the summarize there of the four benefits. So let's proceed to the next one. We have the role of the network layer addresses. So we have here the network portion and the host portion and the source IP address and the destination IP address. So for the network portion, it indicates which network and IP address network the IP addresses is a member. So all devices on the same network will have the same network portion and address. So for the host portion, is unique for each device network. And for the source IP address, it is the IP address of the sending device. So it is the IP address where we'll send something, and that's for the sending. And for the destination IP address, It is a IP address for receiving device. So let's proceed to the next one. We have the role of the data link layer addresses. So we have here the source MAC address and the destination MAC address. So the device that sends the data link frame with the encapsulated in the packet. So the MAC address of the internet NIC of the given here, for example the PC1, is written in the decimal notation, hexadecimal notation. So for the destination MAC address, we have when receiving device is on the same network as the sending device. So this data link address of the receiving device. So for example, the destination MAC address is the MAC address of the FTP server. So it is also written in the hexadecimal notation. So that's all for this video. Thank you for watching. See you again on the next video.